All right, today we're going to talk about one-step equations with integers. So same thing we've been doing, except we're throwing integers into the mix. So let's just review the steps for solving equations first, because they're about the same even with integers. We ought to remember now what the first step is. It's to write the equation down, okay? Once you have it written down and you look at it, you need to ask yourself a question. Is the variable isolated? If you answer yes to this question, you're just going to do the math, okay? The variable's already isolated. Go to the opposite side, follow your order of operations, and simplify as far as you can. If you answer no, show the inverse operations on both sides of the equation. So far, this is exactly what we've been doing, okay? Step number 3 is where the twist comes in. You're going to solve it, but you have to follow your integer rules, okay? So you might want to go over those before you start trying to solve these equations. I've got 4 examples for you, one of each type, and I want you to take a look at it. We'll walk through them together. The first example is an addition equation. It says x plus -2 is equal to 7. Well, is the variable isolated? No. What are they doing to it? They're adding -2. What is the opposite of adding? You got it, subtraction. What are they adding? -2. So we need to subtract -2 from both sides of this equation. Okay, it's important to remember that if we're adding a -2, we have to subtract a -2. Well, on the side with the variable, those we've learned cancel each other out mathematically, and we've got x by itself. On the other side, we have 7 minus a -2. Well, we know from our integer rules that when we're subtracting with integers, we use keep, change, change. And when we do that, we're going to get a solution of x is equal to 9. Okay? The one there on the right is a subtraction equation, and it says d minus -5 is equal to 12. So let's take a look at that. Now, is the variable isolated? No, it's not. What are they doing to it? They're subtracting -5. Well, what's the inverse or opposite of subtraction? What undoes subtraction? Exactly, addition. So we need to add a -5 to both sides of the equation. Okay? We've got to follow our integer rules. We know that when we're adding and the signs are different, we subtract their absolute values and take the sign of the one with the higher absolute value. So on the side with the variable, we know they cancel out. On the side, the right side, 12 plus a -5 is going to give us a solution of d is equal to 7. Right. Let's take a look at a couple other examples. You've got a multiplication and a division. Okay. On the multiplication, it says -7 times c is equal to 56. Is the variable isolated? Nope. What are they doing? They're multiplying it by -7. What's the opposite or what's the inverse of multiplying? Division. So we need to divide both sides by -7. So we show divide by -7 on both sides. We've learned now that on a one-step equation, when we do the inverse operation, it isolates the variable. So we have c by itself. On the other side, we have to do 56 divided by a -7. Well, a positive divided by a negative is going to give us a negative answer. So our solution would be c is equal to -8. All right. One last one for you here. On this one, we have b divided by 8 is equal to -6. All right. Is the variable isolated? No, sir. They're dividing it by 8. We have to undo that division, and we remember that multiplication undoes division. They're dividing by a +8, so we're going to multiply both sides by a +8. So when we multiply both sides by a +8, on the side with the variable, the 8's will cancel out mathematically. It leaves us with b. On the right side of the equation, we have a -6 times 8. We know that when we multiply and the signs are different, we're gonna end up with a negative answer. 6 times 8 is 48. So our solution would be B is equal to negative 48.